All right. So we've got, so far, what's starting to look like a power supply. We've got our power control module, main filter cap. The power rectifier is underneath on the same heatsink as our pass regulator, as well as the 0.1 ohm shunt resistor. This is going to help keep the power supply from exploding because the power supply will have some internal resistance, but this is also going to act as our shunt unit for our current sense. We've got our main heatsink mounted and machined, and I had to make a back plate. I didn't have one, so yeah, these bends were supposed to be inside, but I was having a bad day today. So the one bend is inside. It's hard to do this at home with the horror fraught sheet metal bender, and plus this is the second bend, so you can't do that with that thing. You have to use the things that go on the bench vise. But this I bent by basically by hand and by hitting it with the hammer, and the other one I did bend with the bench vise thing. You see all the metal splitting here because aluminum just doesn't stand up to that kind of pressure. The bend radius is just too tight on the bench bender. It works great on steel, and it works really good on stainless steel too, but this is just, it's too much bend pressure for the aluminum. It starts to fold and crack. So yeah, I was having a bad day today. I guess I sort of still am having a bad day, but we didn't ruin the heatsink, which makes it a good day. And we got all the holes drilled out, so I got the holes mounted, the holes for the mounting of the heatsink, and I got the bracketing in there, and there's some margin in here between the flange and the sheet metal, so we have clearance space there. And I have clearance space here for wire, which is good because the wire has to come from the emitter down to the shunt resistor, and then it's going to go from shunt resistor to the output module, and then the shunt resistor is going to go out to the meter preliminarily, and then we hope to make an auto ranging circuit so that as the current increases, you'll have a low range and a high range. So you'll have more resolution on the meter because the meters only give you 2,000 counts, which sucks. But that's the way the chip was made. This is a ICL 7107, I believe. I think the 7106 is the LCD version. But beautiful chip. Absolutely love the chip. Very easy to set up. Used everywhere. But they decided that they were only going to do 20,000 counts. I think it's the clock speed of the CMOS. I'm not sure, but it was a design compromise, I'm sure. But it only goes up to 20,000 counts, which I've always hated. But if you want, I'm sorry, it only goes up to 2,000 counts. If you want 20,000 counts, you have to pay, God, I think it's an extra, I think it's $125 for a Simpson module that does 20,000 counts. It's a lot more money for that one. But anyway, we're starting to look like a power supply. So I guess I've been dreading this, but I guess soon to be 16-pound monster rewind. You got some bitch. That thing's big, isn't it? Yeah. Big sumbitch. So I got to cut the windings in half here because I need 12-volt windings. And then the trick is going to be, where do we put all the terminal strips and barrier strips and all that other shit in the box so that we can configure as we go. That's going to be a bitch. And I don't have the power entry module yet. It's right here. But I haven't figured out where I want to put him yet, because I'd like to put the capacitor here to recoup some of that lost volume. Yeah, we're getting silly now. Anyway, so I'm not sure where the power entry. Should have bought smaller capacitors. So we have to think in 3 dimensions here. I mean, obviously we have something magical happen here where we actually have enough room for everything. I don't know how that happens to me. Sometimes it just does. It's nice when that happens. But anyway, I don't know. So that's going to be the next hurdle, is sticking this somewhere, sticking this damn thing somewhere. This should be close to the rectifier, actually. So maybe I'll go here. I don't know. We're going to use such heavy wire that it doesn't really matter. We're going to use 10 gauge. The relays will go underneath here. We're going to have ranging relays that will do the tap selects. So we're probably going to have 4 tap selects up to 38 volts. I don't know. I have to figure out what the loaded and unloaded voltages are. So I'm not sure. This is a guesstimate based on the bench model that we're working on right now, but it only has 3 tap selects that are working because we ran into core saturation and we ran out of headroom from the transformer because we were trying to pull 1,000 watts out of an 800 watt core. This is a 1,000 watt core. So we're going to try and get 30 volts at 30 amps. It's 900 watts. We might be able to get 1,100 if we really push it. I don't know. These cores are very, very exact in their size. It's hard to overdraw these guys. An EI core, good one, you can probably overdraw it to 150%. But these guys are so engineered that there's not a lot of margin on them. In fact, I'd almost say don't even expect more than 100%. I'd only probably use it to 95% of the core rating. So we're probably only getting 950 watts out of this bad boy. Because after that, the core starts to saturate and your input current starts going way up. Anyway, that's a lot of rambling. Probably too much. But it's looking good.